You're Arjen.
Yes.
You work on a project called
Tollgate.
Tollgate.
Yeah.
Tell us about this project. What is Tollgate?
Yeah. So Tollgate is both an idea and a protocol,
Yeah.
and we're trying to basically enable bottom-up bottom-up building of physical digital infrastructure.
Okay.
Meaning we want to enable people to build their own, basically start digging their own internet cables and buying and selling internet from each other.
Okay. So it's like peer-to-peer internet.
Yeah, in a way.
But in order to do peer-to-peer internet, you kind of need a way to manage peer-to-peer internet, right?
Yeah. So one of the big problems you would have in the current internet is that accounting, right? Someone's paying for the cables and the data centers in between, and you need a way to compensate people for that.
Okay.
And currently we have a bunch of monopolies that own all the cables, and
Right.
right. So
They own the cables, and so we have to pay them to use them.
yeah. And I mean, internet is relatively cheap, so it's not an issue.
Depends on where you live and how many
Exactly.
providers you have. Yeah.
So historically, you always need a big company to come in and provide that and do everything at once. So what this enables is because the protocol is basically a way to pay each other for access.
Okay.
And once you enable people to pay each other for access, you don't have to go over every month and do all that accounting with your neighbors and whatnot. It just happens automatically.
So as you're using the service, you pay for it.
You just pay as you go.
And it's a digital service, like access to the internet, or like,
Yeah.
I guess it's like number of packets sent, number of packets received.
Yeah, it's either time, you get so much, like you get an hour of access for a few sats, or you get a gigabyte, like how you'll get your mobile phone plans, basically.
And so the accounting mechanism that you're using then is Bitcoin.
It's Bitcoin.
Okay, cool.
We're using eCash. That's because it has a couple of unique properties. One, you can do a lot of very small payments. We don't want to buy for an entire day at once. We just want to do like 1 minute, 1 minute, 1 minute, 1 minute.
Okay.
So you just pay as you go. You just walk away and you stop paying.
So it allows for more granular accounting, basically.
Exactly.
Okay.
Yeah.
And it's, well, I mean, because like one of the things is like it's expensive to do accounting usually, right? You need an identity. You need to know where to send a bill. You need a credit card processor or like some way that they can physically send you money, which usually means you need a bank account and you need like a corporation license.
Yeah, the overhead is so big, like no one in their right mind would even try to do that.
Right, and that's addition to having the pipes available and the network that people are connecting to.
Yeah.
Okay, and so you guys are getting around that accounting problem, so to speak, by, okay, we're going to use these little pieces of Bitcoin or eCash notes.
Yeah.
Okay, and so how does that work then? So if you wanted to set up a Tollgate, what would the process be like to set yourself up, I guess, for business?
So a Tollgate can, basically any hardware can be a Tollgate, since Tollgate is a protocol. So you only need something that can take a network cable or it has an antenna for Wi-Fi.
Okay.
That's basically the core thing you need to operate a Tollgate.
Okay.
And allow anyone to connect to it. And then when someone wants to purchase some internet, say I want to purchase 5 minutes, they need to already have some eCash on them because they are offline. And eCash, that's one of the properties, it works offline.
Oh, right, because I'm trying to connect to a network.
Yes.
Because I don't have connectivity.
Exactly.
Okay.
So that's why you need eCash, because eCash you can keep offline and the router is online, so the router can verify and say everything is good. And then once the payment is in and valid, it just opens the gate for the allotted amount of time or data.
For 5 minutes. That's cool. So one prerequisite is that potential users must already have eCash available, purchased, etc. So like maybe a good example is this: if I have like a router at my office, for example. I want to provide internet I want to have an open internet so that anyone who wants to use it can. Tollgate would let me meter it though, so they would pay me a couple sats in order to access my bandwidth.
Yeah.
That's cool. Is that like, I mean, do you guys have, so that's like a really cool concept. There's a couple things that need to happen. Well, it seems like the most important thing in able to make that work is you need people to adopt eCash and have it available on their devices. And then I guess like what is it like? How would you make that work on like a device layer? Like, would my phone need to download a certain application that's like paying to the Tollgate?
There's several ways to go about it.
Okay.
So the app would be one thing. Like you can have an app that holds a bit of eCash balance for you. You can just top it up with Lightning, and then you connect to a network, and it starts paying for you. Does everything in the background.
That's cool.
That's a state we want to get to. We're not there yet.
Okay.
Another way you could basically offload it to a router, a Tollgate enabled router, is you just have some balance on one router that creates a network just like you have at home, maybe with a password if you want. That just has the money and pays the other Tollgates.
Okay, so it almost be from router to router.
Yeah, most of the payments would be from router to router, and then there's the last step in the chain, just like you sitting in a coffee shop. You are at the end of the network, and the person at the end has to pay, or someone has to pay for them. And the router can do that for you if you own the router. You just put money on there, and it does it on your behalf.
Cool. Cool. So where are you guys in the project? You're writing, the software that you're writing is the protocol that, so you guys are
so
designing.
There's two parts to it.
Yeah,
there's the protocol where we just say like, this is what the payment looks like. These are the parameters, right? How much time, what's the cost, and what are the eCash mints, the eCash banks that you accept.
Okay.
So that's one part. And then we have the implementation that implements the protocol, and we want multiple implementation. We want everyone to make their own implementation that suits their specific needs, either geographically or whatever their business is.
Okay.
So our reference implementation, we account for minutes, and there's a captive port. We implement it as a captive portal, just like you have at airports. You connect to the Wi-Fi, it pops up, and you paste in some eCash, hit connect, and then the money gets sent to a router.
And then the router maps it to your device connection, and as soon as the lease of internet that you've bought runs out, you lose internet access until
unless you top it up.
Right, unless it pops up a new portal and you can paste in new eCash token. That's cool. And are you guys writing this in Rust? What's the implementation?
Our current implementation is written in Golang.
Oh, very cool. That's one of my favorites. Okay, cool.
Yeah, we found out that it's actually possible to put we also use Nostr for the identity part.
Okay.
We do cycle the identities for privacy reasons, you don't want to reuse your identity for payments.
You use Nostr for the identity for the device connection?
Yeah, for one connection, so you can easily top up the same, extend your session.
I see.
But then when you walk away and come back again, you would want to rotate that, just like we do with MAC addresses often. Yeah.
Cool, okay.
Sorry, what was the rest of the question?
Right, so you're writing it in Golang is the first initial implementation, and the project that you're building is something that someone would run on a router?
That's our first implementation. We're hoping that to also get it to stuff like Raspberry Pis, any spare laptop, existing routers from ISPs that are popular in the country, so you can just
a Cisco router or something?
Yeah, if you already have, the cheapest stuff is the stuff you already have.
Yeah, definitely.
So we have interest from communities that are we have, all these same routers from this one ISP in the country. Maybe you can reuse them.
Cool. Cool, okay. And so, when you finish, I guess, what state is your Go implementation at? Is it I have a router in my office at home? Mm-hmm. Is it possible that I could go and add it to my router already? Or are you guys, in beta phases?
Very much beta in that sense.
Okay.
But we build a package for OpenWRT. And OpenWRT is basically Linux for routers.
Yeah.
And a lot of routers are compatible with that, so you can flash it on there.
I think the new one I just bought is an OpenWRT one. Cool.
And we also make a completely finished OpenWRT image that either you can put on a couple devices that we test on ourselves, so you kind of know it's going to work on those.
Are you guys selling devices already packaged, or is this is it still
it's
the
still
DIY?
Demo. Yeah,
okay.
We're still trying it out, gathering a lot of feedback from people. That's our core objective now, and getting the payouts working. First, we stored all the eCash on the router, which is a problem. So now we keep a little small balance, because otherwise you would have to like go in and get the money yourself. Now we store a little balance, and when it reaches a certain threshold, we just pay out to Lightning.
Oh, it auto pays out.
Yeah,
That's
to
cool.
a selected range of addresses. So you can even split it. So you say like 70% goes here, 20% here, 10% to
That's an
whatever
interesting,
person or cause you want to send it to.
That's cool. Like that's an interesting, I would say almost like wrinkle to, like, I wouldn't have thought like, oh right, because the router's collecting the sats.
Yeah.
And then we have to go somewhere.
Yeah.
So now do you have to worry about router security if it's got all this e-cache
I guess,
on it?
It's
Okay.
Routers get worth more now.
Yeah, exactly. Like a little honeypot almost. I guess
Yeah.
that's where the limit comes in, right? It auto pays out.
I guess it's a good practice too. You know, all the security research are going to be all over because the reward is on the router.
Right. Yeah. Oh, that's a good point.
Yeah. If you
like,
get in, it's yours.
Yeah, you can get the sets or just what's left there or whatever. That's cool. So what were like some of the challenges around building like the first version?
So the person that came up with this has been walking around with this idea for well over 10 years. You know, routers paying routers, and it's been like a huge search on like how do you get there? There's there's been a lot of attempts before. It's not an easy thing. There have been moderately successful companies that did like sort of something like this.
Interesting. So like packet metered internet is new. Like being able to pay per like
no, the concept is not new, but I think this will scale because it doesn't depend on any one company.
Right, but is this the first? Is the Tollgate protocol maybe the first protocol that built a maybe scalable design for that kind of like interaction?
I believe so. Yeah.
Okay, cool.
I think at the previous attempts, the bottleneck is the accounting usually.
Right, and you solve that with Bitcoin eCash.
Yeah, you only have to worry about one hop in the system at any point. Like it creates a free market of connectivity.
Right.
So everyone worries about themselves. They buy and they sell. And if
markets,
if they don't turn a profit, then
digital market,
they disappear. And if they see a gap somewhere, then you can make some money, which I think that dynamic will bring accessibility to internet in places where it wasn't before, because someone can make some money on it.
Right. So what's the discoverability? So like one thing with markets is usually you need like some amount of discoverability to find out like who's offering Tollgate, etc. And you're gonna have you're building a network, right, of routers that can pay routers. So you have to bootstrap this network somehow, right?
Yeah.
To make it work. What thought, if any, of you guys put into how to bootstrap that?
There's some ways and we can do it. Like one is obviously physical cables. You need a human to connect them, unless the AI robots get that far. But we're not there yet.
Got it. Okay.
But Wi-Fi wise, we can get Wi-Fi router to connect to another Wi-Fi router. We can do advertising in the what's called the beacon frames. It's the data packets that get sent out along with the Wi-Fi name. So if you go to your Wi-Fi settings, you see the list of Wi-Fi access points.
Yeah.
That list that comes from that same data, and we can add some data to it.
Oh, that's cool.
So basically say like, hey, I'm here, I'm a Tollgate. This is my pricing model, and please purchase from me. And they can probably look around and undercut each other and all kinds of fun stuff.
Yeah, that is interesting. Cool. So, what's next for the project? You're at the point where you're working on this. It sounds like you have a beta, maybe beta the right word for the OpenWRT gateway.
Yeah.
And that's kind of like at the airport captive portal is the right term for that?
Yeah.
Okay, so you've got that done.
Yeah.
What's next? Like, what are you working on? What's your big focus of the project right now?
So right now, it's going to be the router-to-router purchase. We've had it in some earlier proof of concepts. We know it works, but we now have a better platform to work from, a better foundation.
Cool.
So our next focus now is to enable the router-to-router payments. So all that, what I just described, it gets, you don't have to worry about that.
Cool.
You don't have to do it manually.
Yeah. So if people who are listening or just finding out about Tollgate for the first time through this conversation, and they're interested in partnering or building or setting one up for themselves, what's the what kind of participation or help are you looking for, and then how can they find you?
We're hoping to, first of all, get people to test it. So mostly developers right now, like technical people that are like want to test it out and give us feedback. And if they're interested in working on something like an app, right? I'm not an app developer. I'm a bit of a prototype, and it kind of sucks. But you could validate some ideas, and it would be really cool if someone comes up with with an app that does that for you. Same for desktop, and that's basically we want to get developers. Yeah.
So more developers, and you guys are going to be speaking of getting developers, you're going to be at Bitcoin in Riga.
Yes.
Presenting on the project, and we're going to have a hackathon. So hopefully you guys will be available to help teams that want to build on it, explaining it. Maybe we can get you guys to run a workshop or something if that's like on your stuff. So if you're listening and you're interested in coming and meeting the Tollgate team and building on the project and contributing, we'll be in Riga August 7th to 8th. Otherwise, are you on Nostr? Are you on Twitter? Are you on GitHub? All the above? I can also put it in like the show notes.
Yeah.
Okay.
You got tollgate.me. It's kind of the easiest point to find us. And there's the Tollgate Nostr account.
Okay.
And some people from the team I can send you the npubs.
Perfect.
This episode is brought to you by BTC++, the premier technical conference series for Bitcoin developers. BTC++ is not your typical Bitcoin conference. It's a world-class gathering of engineers, hackers, and builders focused on the cutting edge of Bitcoin development. From protocol research to Lightning, smart contracts, covenants, privacy tools, and beyond, BTC++ dives deep into the work that's shaping the future of Bitcoin. Join us for our next event in Riga, Latvia on August 7th and 8th, focused on Bitcoin privacy, and see all our upcoming events across the globe at btcplusplus.dev.
Hey guys, we're back with Arjen. You were about to say something about your background, right?
Yeah, so I come from basically DevOps, CI/CD stuff. So pipelines, that was kind of my jam. Yeah.
Pipelines. What kind of pipelines? Like for Golang projects or?
No, not specifically. Like microservices, like the whole AWS Azure stuff, which now having discovered Nostr, I think is utterly outdated, and we should never turn back to most of it.
Do you think AWS is outdated, or?
A lot of the services, I think, are completely redundant by Nostr, like the simplicity of Nostr and the scaling.
Oh, I see. Like, could you give some examples?
Maybe it's a bit too bold of a statement.
Yeah,
right?
So what we were talking about before we turned the camera on is about how difficult it is to run your own infrastructure, especially when you're building projects. So you're working on Tollgate. It's a 3-person team. You guys need an Nostr relay.
Yeah.
And you were trying to run one yourself. It went down.
At the worst possible moment, and you have to, fix it up, and it's much better in our situation, I think, to just like pay someone that's, really good at that one thing and just do that for us.
And you guys are using who for your Nostr service? I get your Nostr router now.
Right now I was doing it myself, but I heard about Eggster.
Okay.
Yeah, and it's like $20 a month, and you get a relay, Blossom, even LB Hub, all in one go.
And LB Hub lets you do Nostr Wallet Connect stuff, or why would you want to run LB Hub as like an add-on?
It was that's just part of the package.
Okay, cool.
That's my like 2-minute observation.
Yeah,
so I have to like look into it, but they seem
cool. And so this is all stuff you can run for $20 a month on a server that they're running then, basically.
Yeah.
And they're experts at running Nostr software, I guess.
That's what they're specializing in.
Cool. Yeah. So you guys are, sorry, go ahead.
Yeah, I think the difference with like the traditional architecture you need as any business to operate on, a lot of it has been always like you start to go into custom stuff really quickly.
Right.
And I feel with Nostr being, relay based, having Blossom servers.
What's a Blossom server?
Blossom is basically Nostr for files.
Okay.
It's basic. It stores every file, just gets a file hash.
Okay.
And the file hash is the fingerprint of the file, and that never changes regardless of who stores it.
Okay.
So that means that if you have a file and I tell you like download this file, and I can point you to it's on this server, then you can get it from that server, or if it's down, if it's gone, or whatever, you can take it from any other server and be sure that you get the right file.
Because of the hash.
Because of the hash.
Cool. So you get Blossom servers. Okay, sorry, I interrupted. You were saying you get Blossom servers.
Yeah, so they're like, now we have like these simple building blocks that kind of make up the ecosystem of everything that you need to operate any kind of business. Because most of your like text data is on Nostr relays. You don't have to host them yourself because there's so many of them.
Right.
Blossom servers, again, there's so many of them.
Right.
You might just have to pay a little bit, but that's fine. And then you have Lightning, basically Lightning nodes and mints. Well, most of them you don't have to run yourself.
Right.
Lightning nodes arguably might be a good idea, but you know, and I feel like you can basically build anything on these couple pillars.
Got it. Because you have payments through like the mints and
Yeah.
you have payments through the mints and Lightning node. You get
Storage is covered.
Storage through Blossom.
Yeah.
The Nostr relay is like a messaging bus basically for coordinating messages between all these different applications and services.
Which keeps blowing my mind. Like you get message bus capability out of every application that you build without any effort.
Yeah, that is really cool. I feel like you know, in the wider, I hate to almost say it, like crypto ecosystem, for a long time then there's been this really cool narrative of like, oh, Web3, like you can just build the front end, but like the data, the communication layer is all taken care of by blockchain.
Yeah.
Nostr's kind of a similar thing.
I would say, yeah, I think Nostr does pretty much everything that all the Web3 projects claim to do or aspire to do.
But we're more decentralized.
Also decentralized and without the need of a blockchain.
Right. Well, yeah, that's cool. With Bitcoin, though, is the payments. So
and that's the payment
layer. So you kind of touch it. But there's so many layer 2s for Bitcoin payments now that you could exist in this ecosystem without ever going to chain, right? Like you can use eCash to send out small amounts.
I think eCash makes the most sense for, you know, the small payments, the streams, etc. I think I see, you know, the different layers. I kind of see Bitcoin as like you use that to buy your house, Lightning to buy your couch, and everything above to buy your eCash to buy your coffee and all the small day-to-day
that
things.
makes sense. Yeah, that's kind of funny because I worked on Lightning for a long time, and Lightning was supposed to be for your coffee, but it's like graduated almost. I feel like it's like no, now we have like an even like younger brother sort of seat. That's like the eCash thing, and it's even smaller, tinier payments.
Yeah, and now, you know, there's already a guy working on eCash mints with MSATs, millisats.
Oh, cool.
Because with Tollgate, we're starting to run into a problem probably very soon that sats will be too expensive to do very small granular payments. Because, you know, suddenly if you have to buy at least 20 minutes of access, well, you might just be here for 5.
Right.
You know, that starts to be a problem rather quickly.
It's pretty cool that Lightning built that in, I think. Like
they do, but it's not an obvious thing when you're interacting with it.
Interesting. Okay.
Yeah, but I know it's possible.
So you can denominate. You can send Lightning payments in denominated millisats.
Yeah. But how does it work with the settlement? Because like you're gonna have to round.
This is a great question. Point. Yeah. So I actually have a whole talk that I gave at the very first Bitcoin conference in San Francisco.
I love how there's minor details you can give entire talks and write papers on.
In 2019 about where the millisat stuff goes, and even it's not even millisat. So the thing is, you can't settle that on chain.
Yeah.
So there is some rounding. And it's not even at the millisat level. It's even, you know, there's a minimum output size that you can have on chain. So there's like a dust limit for outputs.
Oh, okay. Yeah.
So it's like it's not just
it's kind of negligible
the
anyway.
millisat thing. It's like there's like a couple hundred sats that literally aren't unsettleable to some extent.
Yeah.
And so I have like a whole talk about like how does it handle it in the protocol for when you're sending payments at that level.
Okay.
But yeah, the millisat stuff, like the 2 nodes keep track of.
Yeah.
It's just not represented in the
user
contract.
Interfaces.
No, it isn't represented in the user interfaces, so you're able to send it. Though my recommendation has been for Lightning devs, and if eCash people go this way, I would like really strongly encourage people to show it in the user interface as sats with a decimal point.
Yes, I was thinking about that.
Please don't. Please don't expose millisats to users. Show them sats with like up to 3 decimal places.
Yeah. Even without that, I've sent 10 times as much by accident before. So
I just I think sats is the standard.
Yeah.
Would be my and like I've told people this that are designing. Lightning interfaces as well. It's Satoshi's all the way down, but you can put up to 3 decimal places, and it will be up to 3 decimal places, like exact, if that makes sense. Anyways, that's really cool to hear, and kind of interesting that it's cool that eCash is like adopting, finally figuring that out.
It's I guess it's a funny problem to have when you need less and less sats to achieve the same thing, and you just get closer and closer to the point where it's no longer divisible.
Right, exactly. And it's cool that like I think the Lightning spec developers were prescient enough to be like sats aren't
think about
small
it.
enough.
Yeah.
We need to go 1,000ths of a way down.
Yeah.
Basically, so it's cool. I mean, protocols are so powerful, right? Like the time and energy and engineering that gets put into these protocols is some of the most important work that you can do, I think, in the ecosystem, like in an open source, like decentralized protocol-based ecosystem, because that does define the capabilities of what's possible in the future. Like how long is that protocol like useful? And
I think a massive compliment to all the cashew devs out there was that here at the conference they announced chorus.community.
Yes.
They built it with vibe coding in 4 days, they said.
Yeah.
And it has its own cashew mint. So we walked out, and the demo models for the tollgates that we have, I added that as an accepted eCash mint.
Oh, super cool.
And you could pay with the Chorus app immediately.
Oh my gosh, that's so
like
cool.
That's the,
I want to play now.
Yeah,
okay.
that's the protocols over platforms thing. I have to ask no one
right, for
and
permission.
start accepting whatever is in their app.
Oh, that's cool. Because I actually went and put, they gave away like $5 to everyone that was here, and I missed that.
That's why I was like, I have to put it in there, because then anyone that was in the room already had the app. And
are you guys running a
with
Tollgate here at the conference?
Yeah, it's right downstairs.
Oh, okay,
Yeah.
cool. All right, I'll have to go see if I can connect to that. That sounds like a fun thing to experiment with. Cool. Great. Okay, well, we've chatted a lot more than Arjen. I think people are wrapping up here, so I'm going to head out. But thanks again for your time, and looking forward to seeing you in Riga soon.
Yeah,
sounds good.
Thank you.